Hello students! So this video here, or this little mini lesson, is going to be on multiplying two polynomials. Again, a binomial is where you only have two terms. For a polynomial, we're talking about trinomials or even possibly having more than three terms. I'm not sure how many of you guys remember something that sort of looks like this, and they may go all the way to 12 or all the way to 13. But again, the box method is something similar to that. And you guys should kind of remember something about finding area. Like if you had a rectangle like this one, even if it was a square, you multiply this side times that side. And so again, I'm going to show you how to use the box method. So let's just look at a very, very simple example here. This is just to show you that you can use the box method with any type of polynomials, period. You can change the dimensions of the box that you're using based on how many terms you're multiplying in each polynomial. For this particular multiplication, you're multiplying one term times two terms. So clearly, on one side of the box, you're going to have a place for one term to go, and on the other side of the box, you're going to have a place for two terms to go. In other words, the dimensions of this box are going to be 1 by 2 because you're multiplying one term times two terms. And again, you're going to distribute this term to these other two terms. 3x to the third power times 4x. So again, clearly in this first little box here, you put the result of multiplying these two things on the outside there, right? So 3x to the third times 4x, and that is 12, right? 3 times 4 gives you 12. And how many x's do you have all together? You guys should remember what to do with the exponents when you're multiplying these things and they have the same base. These have the same base, x, right? So that's going to be x to the fourth power, because remember, you add the exponents. And then, of course, to get what's in this box, you multiply 3x to the third times negative 2. All right, negative 6x to the third. So we've got two terms that are resulting from that, 12x to the fourth and negative 6x to the third. Remember, folks, that again, when you're using the box method, the box's dimension depends on the number of terms involved. So, in this next example, let's say that we were dealing with multiplying these two polynomials. One of them is a binomial, the other one is a trinomial. So again, one of them has two terms, the other one has three terms. That lets us know what the dimensions of our box needs to be. So we need to do the dimensions of the box as 2 by 3, or we can do the dimensions as 3 by 2. It actually does not matter on that end. As long as one side of the box has two parts and the other side of the box has three parts. So, folks, we're not going to do both of these because again, these are going to give you the exact same result. I'm just going to work out this one because my hand is already over here. So we see at this top row, we're multiplying the 14 times each of those parts at the top, right? So in the first box, we're going to multiply 14 times 2x squared, which gives us 28x squared. In this next box at the top, we're going to multiply 14 times negative 15. That is negative 210. In the last box at the top, we're multiplying 14 times 3x, which is 42x. So at the bottom, we're distributing that negative 8x cubed times all three of those parts. So negative 8x cubed times 2x squared gives you negative 16x to the fifth, excuse me. All right, we multiply negative 8x to the third times negative 15. Negative 8 times negative 15 gives us positive 120. And then for the last thing, we multiply negative 8x cubed times 3x. That gives us negative 24x to the fourth. The box method is really just a form of extended distribution, okay? And I personally prefer to use the box method with multiplying any types of polynomials. Again, you don't have to use what I like. All right, so we wind up having 6 terms here. And again, I'm going to require and ask that you write your answers in standard form. Remember, standard form is being ordered where your exponents have to go from the highest to the lowest. So if we start off with our highest exponent, standard form, negative 16x to the 5th is the part that comes first. So clearly, guys, if there is a minus sign in front of a number, it's negative, but of course, you're going to write it as minus 24x to the 4th. If you don't see a particular sign, clearly it's positive, but again, if it's positive, like what we're writing here with the 120x to the 3rd power, you should write plus 120x to the 3rd, okay? So here's all 6 terms written out. It's in standard form, and okay, we do not have any like terms that we can combine here. So we are done in this case. This is simplified as much as we can simplify it. All right, so let's look at this example next. And some of you may be looking at this like, whoa, 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 whoa. Now, wait a minute now, Mr. Starkey. Look now, you doing too much right now. Okay, this one has 3 terms. And this one has how many terms? 5 terms, Mr. Starkey. 5 terms. What are you doing? Huh? What are you doing? Why are you doing this to me, Mr. Starkey? All right, that's enough of that. Anyway, the dimensions of your box here, using the box method, should be 3 by 5. So I'm going to put 3 options on one side and 5 options on the other one. If you get confused, just turn your paper this way, okay? If you want to do yours that way, just turn your paper that way. How about that? Okay, so in my dimensions are 3 by 5. Again, if you wanted to put 5 terms vertically, and yours was long this way and short the horizontal way, 3 by 5. If you wanted to do yours that way, that's fine. But again, I'm not writing it out that way in this example, okay? You'll still get the same result, or you should. I'm going to go ahead on and do this whole top row. 7x to the 3rd times each one of these. So 7 times 8 is 56. Okay, when you put all the x's together, that winds up being x to the 4th. 7 times 2 gives you 14. There's only 3 x's here. 7 times negative 1, negative 7. Put all the x's together, because remember, you're multiplying, you add your exponents. X to the 5th. 7 times 9, 63. Put all your x's together. X to the 7th. There's a total of 7 x's there. All right, and then 7 times negative 6, x to the 5th. That's negative 42. And put all your x's together. That's x to the 8th. Now I'm going to do this middle row. I'm going to distribute negative 4x to each part up here at the top. So negative 4x times 8x gives you negative 32 x to the 2nd. Negative 4 times 2 gives you negative 8. There's only 1 x there. Negative 4 times negative 1 gives you positive 4. And you wind up having x to the 3rd, excuse me. Negative 4x times 9x to the 4th gives you negative 36x to the 5th. This is going to be 24x to the 6th. So here we wind up having 15 terms altogether. Okay? As a result, we wind up having 15 terms. Okay? Now, when you do this, if you have a resulting amount of terms that is not the same as this number of terms times that number of terms, you probably did something wrong. Okay? Now, so we wind up having initially 15 terms here. Now, of course, we're going to combine like terms. So I'm going to line mine up, and I'm going to go ahead on and put mine in standard form. Because again, I'm asking you all to write your answers, and I don't think that any of the Delta Math will count your answers wrong if you put it in standard form. but I know that some of them will count it wrong if you don't put it in standard form. So let's start with the highest exponent, because again, standard form, your exponents are ordered, or your terms are ordered from the highest exponent to the lowest exponent. Highest exponent here is 63x to the 7th power. We don't see any like terms for that, right? Nope. Okay. All right, the next highest term, 24x to the 6th. Any like terms with that? Nope. Next highest term, negative 7x to the 5th. Any like terms with that? Yes, there are. I know I'm asking questions and answering them, but I'm not talking to myself, okay? Talking to you. You're just not here to answer me, so I'm going to answer me. And then I think the only constant term that we have here is negative 20. And I apologize if this is sloppy, okay? That's not my goal. My goal is not to be sloppy here, but so we have combined our like terms here. It's already written in standard form because I put it that way and ordered my exponents from highest to lowest. And this here is our final answer. Just want to make one quick, I'm not going to work this problem out, but I am going to just make one quick little point. If you had something written like this and it was squared, okay? This is polynomial multiplication, and it is multiplying two polynomials. Please, please, please do not just say, oh, well, 4 squared is 16, and 8 squared is 64, and 17 squared is 289, and 8 squared is 64. And don't just say, oh, well, if I square x to the 3rd, it's just x to the 6th. And if I square x squared, it's just x to the 4th. And if I square x, it's just x squared. Please do not do that. Remember that anytime you have something raised to the 2nd power, any exponent, it means that it is repeated multiplication. Please remember that this means that this polynomial is multiplied by itself 2 times. So again, you will need to do some type of polynomial multiplication. Again, this is going to be 4 terms and multiplied times 4 terms. You will have a result of 16 terms when you get done, and you will need to combine like terms. I do hope that this has been helpful to you guys with multiplying polynomials. Again, I'm not going to work this out, but again, I do hope that this has helped to explain how to use the box method or the area method with multiplying 2 polynomials.